So, hello everyone. Today I'm going to talk about JavaScript modules and build tools. So, let's say we have a relatively simple program that requires a sum function that will take as input an array of numbers, and it will return the sum of those numbers. And with functional programming, we can assemble this sum function from a reduce function and an add function. And this is sort of a contrived example, but like the reduce, add, and sum functions can all be defined sort of separately, but the sum function depends on the reduce function and it depends on the add function. And then the main program depends on the sum function. So this is exactly what modules are for. You could publish modules, independently of one another, but each module declares their dependencies on other modules. And then the module system or the build system should automatically resolve these dependencies. So what we're going to look at today is these various different module formats for JavaScript, including globals, global variables, which is like the oldest possible module format, and then AMD, asynchronous module definition, CommonJS, and ES6. These are the module formats. And then there are all these different build tools, like RequireJS is particularly for AMD, and then Browserify it was originally for just CommonJS and Node modules, but there's a ton of tooling around it now that enables it to work with AMD and ES6. So ES6 is ECMAScript 6. It's like the next version of JavaScript that's being standardized, hopefully this month. That's what they say. And then there's another thing called Webpack, which will bundle stuff together. And then there's Esperanto and Rollup, which are tools particularly for ES6 bundling. And then there's JSPM, JavaScript Package Manager, which aims to consume different module formats at the same time, which is pretty amazing. So I'm going to go through a bunch of code examples, 19 code examples. So the first one is sort of a monolithic program. It's just one big HTML file. And so just stare at this for a second and take it in. It's an HTML page. There's an add function that just takes as input two numbers and returns the sum of those two numbers. There's a reduce function, which is from functional programming, map and reduce. So for each element of the list, it calls the function that was passed into it with this MIMO value, which is the initial value, and then it changes, each iteration through. It's, one way to implement reduce. And then it returns this. What?
It's immutable.
It's immutable?
It's mutable because you're updating the memory.
Oh yeah, it's mutable. It's mutable. So it's not like purely functional or anything like fancy like that. And then there's the sum. There's this sum function that calls reduce with the list, and the reducer function is add, and then the initial value is 0. And then this is the main program that has an array of numbers, and it calls sum with that array of numbers, and it gives you back the result. And then this is some code that puts the result into the DOM element on the page, this H1 DOM element, document object model element on the page. So it's an empty HTML tag, and then this gets it by its ID output, and then sets its inner HTML to be the result. So what should we see on the page after this program runs? Six. Yeah, so up here I have the running program, and that's what we see, 6. It just adds 1, 2, and 3 together. So this is sort of our starting point for discussing module systems. So this is not using any module system at all. It's all on one page. And in the next example, it's going to use global variables, and each module is in a separate script tag. So this just splits up the program into different JavaScript files, and each of these files introduces a global variable. And this is not really good practice, but it works. And we need to manage the order in which these things are included ourselves with these script tags. So we need to make sure that add and reduce are there before sum is there, and then that sum is there before the main program is there. So in this, so the question is, yeah, where's the global variable defined? So this code here defines a global variable called add.
So is it basically just concatenation?
Yeah, it's pretty much concatenating the files. Yeah, the way that JavaScript runs, which is sort of different from other languages, is like when you include a script tag, it's as though that code were directly put right there on the page. So when you include script tags, it fetches the code and then evaluates it, and then it goes on and fetches the next code and evaluates that. So this is using global variables. When you declare a function like this in the global scope, then it becomes a global variable. Right, there's no namespace here. Yeah. So this is not ideal, but at least now the modules are in separate files. And then there's a namespace concept, still using global variables though. Let's say that we want to have our library called functional utils. And so we can say, there's a global variable. We could put var there, but in this case, this is the same behavior. If you don't include var, it assigns it to a global variable. So this is assigning a global variable empty object, functional utils. And then we're including that first on the page. And then we're including these other files that add properties to that single global variable. And so there's a side effect of this is that like when you want to refer to those things, you need to use the full path, like functional utils.reduce, rather than just reduce. So it makes your code a little bit messy. And then here in the main function, we can refer to functional utils.sum, which was defined here. And I want to talk about this pattern a little bit. This is called a self-invoking function or an immediately invoked function expression. And there's a nice Wikipedia page about this. The whole point of this is to eliminate global variables. So it's a function that's defined and then it's called immediately. And then all the stuff in here is in the closure of that function. So it's not introducing global variables. So before, numbers and result and all that stuff they were global variables, and now they're not. They're contained within this closure. So this is a slightly better pattern. We're only introducing one global variable, functional utils. Oh yeah, so from the beginning, here's the first example. The main program just looks like this. Everything is global variables. Next example, here's the main function. And again, these are global variables, just loaded separately. And then in this namespace example, this is the main function. It's just encapsulated like this, so it doesn't introduce global variables. Oh yeah. I mean, if you just pasted that code into the console and ran it, it would have the same effect. Yeah. Pasting into the console is just the same thing as including a script tag on the page. So far, we're not really using any module systems. These are more like patterns for organizing your code. But it means that you need to manually do this algorithm called topological sort. And topological sort is a graph algorithm that's related to depth first search. And this is the algorithm that resolves the order in which things need to execute in order for their dependencies to be resolved before they execute. So yeah, it takes as input a graph and it gives as output an ordered list. And so all these build systems that exist, like SBT, Make does this, and the build systems that we're going to discuss, they execute this algorithm internally. So we don't have to do it in our head. So we have to do it in our head here to define like which order the script tags are included in. And in this, circular dependencies is a tricky topic. Like you could define it in such a way that it would work, but I don't really know. I haven't really experimented that much. Yeah, you can have circular references here actually, because when this code runs, it does not invoke this function. It just defines it. So
you said like the order in which you include these important styles.
yeah, I mean, depending on how you define the modules, the order usually is important because like when you define the module, there's some code that runs that refers to the other modules a lot of the times, but like in this example, it's not the case because we're just defining functions and not running them. Well, I think it comes to a point of like, I didn't design this example code to highlight the fact that you really need the order of the script tags to be there in that way in some cases. Because in this case, the modules, the functions don't actually execute until the main program calls them. Therefore, the order doesn't really matter because as long as they're all defined before the main program runs, it'll work out. But the main program is a perfect case. Like if we had the main program before this stuff, it would not work because it refers to those things and they need to be defined first. But with modules, even though these modules don't have that property, a lot of times when you define the module, it has to have these dependency modules defined first, usually. So I want to talk about this idea of bundling. So in production, rather than fetching each JavaScript file individually, like in the case of Chorus, we have billions of files, like hundreds maybe. And if you fetch them all separately, it takes like a minute or two for the whole page to load. So in production, people bundle JavaScript files together into one big file. So this is what it looks like. I'm calling it functional utils bundle. So this is the main page. It's just including that one script tag. And that one script tag contains just all the other files concatenated together. And the other files are still there because like you want to author your files as separate, but then when you put it in production, you want to bundle them together. And here I'm using a make file. So make is, I recently started using make. I didn't really use it before, and I kind of fell in love with it. I really like make. It's like really elegant, So if you run make, it will run this command. It's just cat, the Unix command, cat all these files into this output file. So it's like roll your own bundling system, And then when you run make clean, it will remove the bundle. So this is one way of concatenating files together, just to show the basic concept of bundling without using any like fancy tools. And so this works. It loads one file and everything's defined before the main program runs. And then there's minification. So the bundle that we saw before contains this full JavaScript code. But in order to reduce file size even more in production, people do what's called minification. And I think the most popular tool for this is Uglify.js. Uglify. Yeah, it makes your JavaScript code ugly. As if JavaScript wasn't already ugly enough, right? But it's a popular tool. And so what you get, well, here's the make file. So after we've defined the bundle, there's this line down here. Make it a little bigger. Yeah, compress and mangle are these two options. So they're options that you pass into Uglify to, make it really small, make the file size really small. In make files, by the way, you can use this shorthand to refer to the input and this shorthand to refer to the output. So the question is, why would you minify? I mean, sometimes if you have proprietary code and you don't want people to understand it, then you can minify it so people can't like reverse engineer. I mean, they still can try, but. And so this is what you get as a result, the minified file. It's like functional utils.add. It changed my variable names to n and t, and then reduce. It changed the variable names to be one letter. And so it does this throughout the whole file. But still, it doesn't change the behavior. Like it doesn't change the name of the function assigned to the object. So now if we include the minified bundle on the page, everything still works. We get 6. So this is how you can use cat and Uglify together to do bundling and minification. Right. When you run this command npm install uglify.js-g, it uses npm, which is the node package manager and tooling around that. It will fetch the uglify command line tool and install it globally. So then you can just run uglify.js as a command in the command line, and it will run. It will refer to that npm module that was installed, which is super cool. I mean, it makes npm now a package manager for command line tools, which is amazing. All right, so far we still have not used any module systems. It's just sort of leading up to it. So here's CommonJS. CommonJS is it's the module format that Node.js uses, and it was sort of one of the first like standardized module formats. This is what the modules look like now. If we have an add module, we define our function, and then we say module.exports equals add. And module.exports is sort of given to you by the environment that loads up these modules. And you assign an object that you want to export to this module.exports object. And then when you want to use a module, you can say require, and require./reduce, it looks into this reduce.js file, and then the return value from the require call is the value that you've assigned to module.exports. So the question is, does that mean you can have one accessible function per file? No, because you can, instead of exporting a function, you can export an object that has reduce, and then other stuff and more different things in that one object. You can only export one object, but that object can contain many functions. And this is a pattern that you see a lot. The exports thing is an object, and the properties on that object are functions. So the question is, how do you reference one? If there are multiple functions defined, how do you reference one? So let's say there's reduce defined, and then there's like f, which is like some function, right? Just theoretically. If you had multiple functions, you could say .reduce to extract that one out, or you could say like .f to extract the value out, or you could say like, so m now is the value of this object, and you could refer to like m.reduce or m.f depending on what you want to access in there. Yeah, if you use CommonJS modules, you can't just include them on the page with a script tag. You need to use a build tool that understands the syntax of CommonJS modules. So just to complete the example, here's the main program. It requires some, and then it uses some. And it doesn't export anything because it's the main program that just gets run. // that means pull it from a local file that's in this directory. So yeah, it means to use the reduce.js file. If you were to just use reduce, well, actually it might. Right, you don't need to put .js. It assumes that it's a .js. Well, you can only include .js files. So because it's JavaScript module system. So they omitted that from the specification. So yeah, you can put into require a path to a file that's local, or you could put a module name, like uglify.js is actually an npm module. So if you do npm install uglify locally, then you can say require uglify.js, and that will resolve to the npm module that you have installed. So this is how CommonJS and npm can be used together.
So that means it has to go into your code and kind of like execute it.
Well, it does static analysis. It doesn't execute the code, but it analyzes the source tree. It parses the JavaScript, and then it looks for these require statements. And so the program that does this is called Browserify. Well, actually, your question was, does it resolve the dependency graph when you run it or when you bundle it? Well, if you use the modules in Node.js, which is a JavaScript runtime that's like a command line tool, you could write server-side code in it. If you load the file with Node.js, it will resolve the dependency graph only when it runs it. So it's a synchronous call to require all the recursive dependencies. But if you bundle it for the browser with Browserify, then it resolves it all at bundle time when you make the bundle. So this is what Browserify does. It lets you use NPM modules in the browser, or in general, CommonJS modules. It lets you use them in the browser. So in the make file, now it's just Browserify with the input file, which is main.js, and then .o, the output file. And so when you run this command Browserify, it will resolve these dependencies and generate this bundle. So here's the output from Browserify. The first line has some minified stuff that is like an implementation of the CommonJS API, but in a static way. That's sort of self-contained. So it defines require, and then it generates this sort of ugly code that we can see our code in there somewhere, but it's like sort of bundled with this, cryptic stuff that we don't really need to understand. Just it works.
So you have multiple references to the module.
There are different closures, though.
The module becomes a property of the function definition.
Well, module is in this case, Browserify has wrapped our reduce function into this other function that defines module as an argument to the function. So module is only defined within this function closure. And so each closure has its own different version of module that sort of gets resolved. It's not a global. So there are no global variables here in this bundle. It's just one big function. And then you can minify this and get something minified and then include that on the page and run it. It still says 6. That's like our, litmus test. Like, does it work? So, yeah, I don't want to spend too much time dissecting the structure of the bundle that it creates, but this is the first of many bundles that we'll see. This is the Browserify bundle. And so there's another tool called Webpack, which is very similar to Browserify. And if we look at the make file, it just invokes Webpack instead of Browserify. And the modules that we've defined are still the same. They're still CommonJS modules, but the bundle looks different. This is the stuff that Webpack generates. So this is the Webpack bootstrap that defines the CommonJS API within a function closure. And then here's our code that similarly wraps everything in a function that has a module, defined locally in the closure. And it's sort of a nicer format in a way, but then, we're going to minify it so it doesn't matter really, as long as it's not big. And so this works also. We see 6. Hooray. So Webpack is very popular. So the main contenders for bundling CommonJS modules are Webpack and Browserify. And then there's AMD, asynchronous module definition. So the whole point of AMD was to address this problem, this mismatch with CommonJS and the browser, because with CommonJS, when you say require jQuery, it expects that jQuery is returned synchronously. But in the browser world, it has to actually go and fetch that library asynchronously. So the syntax just doesn't work that well. So AMD is an asynchronous module definition where you call a function called define, and the first argument to define is an array of dependencies. And then the second argument is a function that gets called later after all those dependencies have been loaded with the values for those dependencies, in this case jQuery. And then you return something from that function, and that becomes the export object for your AMD module. So in our little example, this is what our modules look like now with AMD. Define, the first argument is array of dependencies. There's no dependencies for these first two, but we still have to include it because that's just the format, that you need to have it like that. And then we return the add function. So we're just returning a function. It's named just for code clarity. We could just write it like this. It returns a function. So this is the export for the module is the function. And so here's sum, which depends on reduce and add, and then those get passed in as arguments here, and then it returns the sum function that refers to those reduce and add functions. So yeah, define is a global that is present in this AMD scheme. So yeah, when you define a module, you call this define function to define your modules. All right, so in the make file, I'm still using Webpack, and I haven't changed any arguments at all. And one amazing thing, I think it's amazing, about Webpack is that it will auto-magically work with AMD modules or common JS modules. Oh, it's just a make file convention. It means like you can run make clean and then you can run make all. It's just like documentation. And .phony means it's not a real task. Yeah. Yeah, so the question is, how does it work in the browser during development without doing any bundling step? That's a perfect lead-in to the next example, which is AMD and RequireJS. So in this example, there's no makefile. And in the index.html, we are including RequireJS from a CDN. So RequireJS, let me just show you the page. It's a module loader that dynamically fetches AMD modules as you require them, and it recursively resolves the dependencies for you. So if we run this example full screen and we look at the network tab, it's loading the require library, and then it's loading main.js. So in the HTML, the main.js script is being included. And that script calls define, which is defined by RequireJS. And then after main is loaded, it loads sum, reduce, and add. And then after those files are loaded, only then does main.js actually execute. And that's what RequireJS manages, that execution flow. Yeah. So this works great in development. And this is actually what I have been using for like years, for like, I don't know, 2 years or something. Because it's so nice during development. And I was in school before, so I didn't have to put anything in production. So I never had to really bundle this stuff. But it turns out when you go to bundle things with RequireJS, things get really hairy really fast. So here's one example that uses the RequireJS Optimizer called r.js. It's built into RequireJS, or like a subproject of RequireJS. And this is what it looks like. We're including a bundle, and then the command that generates that bundle is r.js -o, which stands for options, not output, which is confusing, build.js. And build.js is not the output bundle, but rather it's a configuration file, which is right here, build.js. And you pass in the arguments this way. So already this tool is more complicated than it needs to be. And you need to include all this stuff, which I sort of copy and pasted from the RequireJS page.
This means the system knows how to run r.js.
Oh yeah, you have to install RequireJS with npm first as a global command line tool.
So if you do that, there's like a command line JavaScript interpreter.
Oh yeah, it's node.js. So if you run npm install requirejs-g, after that runs, then you will have this command globally available just to type in r.js at the command line. And what that does is it points to the node module that was installed. Right, what's Almond? All right, so if I did not include anything about Almond, the bundle that it would create is exactly this. It's just these define calls. It's just these define calls with named modules. This is how modules get named when they get put together into one file. Otherwise, the define calls would just be all unknown, like what module is it defining. So this is what the r.js bundler produces. But it doesn't actually work because it doesn't define the function define anywhere. And there's another subproject of RequireJS called Almond. Let me show you Almond. So RequireJS is kind of a big file, but Almond is a minimal AMD API implementation for use after optimized builds. So when you build using r.js, you need to include Almond, which is like a minimal implementation of define and require that assumes that everything is named and just in a bundle. It doesn't do any dynamic fetching at all. So in order to use the r.js bundler, you need to download almond.js locally, which I find crazy. And then you need to trigger the build to include Almond in the bundle. And so what you get is a bundle that has as its first line is Almond as a minified thing, and then reduce, add, and sum. And then the main function. And so like it generates this weird stuff. Like it doesn't really make sense to me, some of this stuff, and it defines Almond as nothing, but this is like the prescribed way to do things. So I got a little fed up with using this toolchain. So there's another thing that you can use, which is amd-optimize, which bundles AMD modules in a different way. But it doesn't have a command line interface, so we can't use make. I don't think it does. It was designed for use with Gulp. And Gulp is kind of like make. It's yet another tool. And so similar to a make file, you have a Gulp file that defines tasks, and then Gulp will run these tasks in the right order for you, kind of like make. So here's our Gulp file. So to run this, you need to npm install Gulp as a global command, and then when you run Gulp, it will, just like when you run make, it runs the make file. When you run Gulp, it runs the Gulp file. But it's actually just a JavaScript program that runs in node.js. So you can require these different modules that are published on npm. And Gulp is based on piping and like node streams. So it takes in all the source files and then just calls amd-optimize, which is this tool that does the same thing as r.js, but can be used within Gulp like more easily. But still, it doesn't define define. So you still need to use Almond with this approach. So here's the bundle that you get. It's pretty much the same as the r.js output. And then on the page, I'm including Almond first, and then the main bundle with all the AMD modules. So this works, but I don't want to have to include two things to run my bundle. You know, the bundle, in my opinion, should include Almond. So I figured out how to do that. This kind of took a while, and it was a lot of modification to the Gulp file. But this was kind of some example code that I pulled. The link is here. There's a recommended modules section of this amd-optimize Gulp plugin. So I took that code, and what it does is it includes Almond and your bundle, and makes sure that Almond comes before the bundle, and then outputs that whole thing into the full bundle. So this is another way of bundling AMD modules. And then now the page just includes the one bundle file, and everything works. So that's amd-optimize. And then there's another tool chain you can use to bundle AMD modules with Browserify. So Browserify originally just worked with CommonJS modules, but there's this thing that they created called AMD-ify, which will transform AMD modules into CommonJS modules and then use Browserify. So now the modules are still just AMD modules, and then in the make file, it's using Browserify-T, which is a transformation, a DAMDify. So you need to install these things first before you run this command. But this works. This does exactly the same thing as r.js plus Almond and amd-optimize plus Almond. And here there's no need for Almond. So in a way, it's a cleaner solution. It's simple. Well, it's for AMD modules. Because a lot of people like a few years ago, evaluated CommonJS for browser-based projects before Browserify was good or existed, and it wasn't really an option. They had to adopt AMD modules for their browser projects. But then over the years, the tooling improved, so now it makes more sense to author browser-based projects in CommonJS.
So which one's better? Yeah.
Which one's better? Good question. I'm not even going to attempt to answer it. They're both terrible. We use AMD.
You said AMD is asynchronous.
Yeah,
CommonJS is not.
CommonJS is synchronous. Yeah, the required calls need to resolve synchronously, so it needs to be bundled. You can't have non-bundling.
Yeah, but if you have huge JavaScript files,
Well, it's debatable, right? And there's other approaches to bundling where instead of one massive bundle, you have one like semi-massive bundle, and then there are other massive bundles that you require on demand. So in the case where files get really huge, yeah, you don't want one bundle, but you want several bundles, but you don't want to go to the granular level of modules. So, I mean, it's a big world of tools. So, yeah, this is how you can bundle AMD modules with AMDify and Browserify. All right, so you asked the question, is AMD or CommonJS better? Like, what should we use today? And my answer would be, we should not use either of them. We should use ES6 modules, which is the next standard, the next like standard, like the, the way, the real way, the one true way. All right, so ES6, ECMAScript 6, there's this great page. This seems to be pretty much the standard. I mean, there is a standard, but it's massive and incomprehensible. But this is a nice thing that describes all the features of ES6. You can use fat arrows instead of writing out function to have lambdas. And you can have classes. JavaScript gets classes and inheritance. Psh, like mind blown, right? And then you can have template strings, so you don't need a template library anymore. It's built into the language. And then there's destructuring. Yeah, no more plus plus. Like you can destructure. This is JavaScript of the future. And so it looks more like Scala. And then there's rest and spread arguments. There's let. There's a new way to do a for loop. There's generators, which is like a revolution in control flow. It's asynchronous control flow. It's just crazy. And then there's modules, which is what I'm going to talk about.
this is a
New version of JavaScript.
Who's supporting?
A lot of people. The browser vendors don't support it yet, but you can write ES6 and then use build tools to compile to ES5, which is the current JavaScript that works. And so the two main tools to do this are Traceur, which is an older project by Google, and then there's Babel or Babel. Oh, we'll talk about that in a second. But this is the syntax for ES6 modules. Just export something and import. And there's different syntax, like you can. So in the ES6 module world, each module exports multiple things that are named rather than just one thing, which sort of makes sense. So you can import, like, let's say pi and sum are defined from mathlib. You can get them both into your local scope. So finally, it looks like a real programming language, with import and export. So this is what the modules look like now. Export default means that when you consume this module in CommonJS or AMD, the single object that gets exported is this one, export default. So export default function add, export default function reduce, and then in sum, we can import reduce from /reduce, which is the file, the local file that's next to this file, and then export default function, and then in main, import sum from sum, and then do our stuff. And so Browserify also supports ES6 using a transformer called Babelify or Babelify. So Browserify-T Babelify, and this is our bundle. I want to show you Babelify, so it's like an NPM module that transforms ES6 into ES5 using Babel. And then browserifies machinery. I think it outputs CommonJS, and then browserifies machinery kicks in on the generated CommonJS. And Babel is this project which is like the JavaScript compiler that compiles ES6 to ES5. This is like the most popular one. And then there's another one called Tresur, and there's another browserify plugin thing called ES6ify that uses Tresur instead of Babel to compile the ES6. So Tresur is from Google, and it's like an older one, but like I think the general consensus is that Babel is like better. I don't really understand it. It's a complex landscape. But this is how you could use Tresur and just use ES6ify instead of Babelify, and you get pretty much the same results. The bundle looks different, but it works. I think Babel has cleaner compiled results, but I don't know really. Just so the question is, if you switch to ES6, can you still have dynamic loading during development and then bundled loading during production? You can with another tool called System.js, and I'll get to that later. So it's kind of like RequireJS, but System.js can load AMD modules, CommonJS modules, and ES6 modules. And when it loads the ES6 modules, it compiles it to ES5 in the browser. So that's possible. And then there's another tool called Esperanto. And if you look at the makefile, it's just Esperanto with a bunch of arguments for the input and the output. And if you look at the bundle, though, oh my goodness, it's so clean. This is to me like a breath of fresh air. Like I've been looking at all these ugly bundles, and then this is like, phew, it's so clean, And then it outputs UMD. So UMD, let me explain UMD. So let's say you're publishing your awesome JavaScript library, right? And you want to publish it to as many people as possible. You don't want to force them to use AMD or force them to use CommonJS. So there's this thing called UMD, which let's take a look at one of these. See, there's all these different versions too, which just makes it even more confusing. So if you want to publish your module as AMD and a browser global, so if the user of your library just loads it as a script tag, it will work as a browser global. But if they include it using RequireJS, it will work as an AMD module, and it will also work as a CommonJS module. There's one here with like all of them. I don't know. It's complex, but you get this sort of ugly header, which is in our bundle right here. So this piece of code right here makes it so that if you load this bundle with a script tag, it will be available as a browser global. And if you load it with an AMD loader or bundler, it will work. And it will also work if you load it as a CommonJS module or try to bundle it as a CommonJS module. So this is super cool. Browserify outputs a browser global because it's targeting browsers only. But probably there's some plugin that will output UMD from Browserify. I don't know. So yeah, Esperanto. It's a pretty cool tool. It's not as mature. It's fairly new. It's by this guy, Rich Harris, but it's like really clean. But it turns out that Rich Harris redesigned Esperanto into a new project called Rollup. And the focus of Rollup is to include only the imports that are necessary. Because like with all these other bundlers, let's say you have a library that's like 100K or something, and it defines like 100 different functions, but you just want to use one function from that, all the other bundlers will include the entire library with all the functions and then just access the ones that you need. But Rollup is a more intelligent ES6 bundler that will only include the functions that you refer to. And the reason I got into this is because Mike Bostock, the guy who created D3, he's working on this open source next iteration of D3. And it all started with D3 selection. If you look at D3 selection, there's an index.js which uses ES6 modules to structure the API. And so he adopted Rollup in this thing called D3 Bundler. It's a Rollup-based solution to bundle all these separate sub-projects of D3 into the one big D3 bundle that people will use. So I said, oh, that looks cool. Like, I kind of want to be on par with like the tools that D3 is using. And so you can just call Rollup as a command line tool, and this is the bundle that it produces. I mean, in this case, I think it's almost exactly the same output as Esperanto, but as the project scales, it'll become more and more important if you have, thousands of files to only include the functions, the imports that you actually use. So this is how to use Rollup. And then there's another tool called JSPM. And JSPM, I found out about it recently by this guy in Japan who sent me a pull request on Chiasm. He's like, you should switch to JSPM. And I'm like, what? But it turns out he's right, because so JSPM is designed to consume all these different formats at the same time. So here's JSPM with ES6. But I started working with it. I don't really like it that much because it introduces like all these files. There's a config.js, and then the bundle itself is massive. It doesn't seem very efficient. Like, it seems like, I don't know, it's all to add up 6 numbers, right? But like, it seems like a little bit overkill to me. I don't know what, I mean, maybe there's a good reason, but I don't know. They're including a polyfill for the future system.loader API and ES6. I don't know. And then, so this is using Traceur. It could also use Babel to compile. And it generates this self-executing bundle. And source maps, so that when you throw an error in the code, the debugger will show you the line number in the original file, which is really cool. These other Browserify and Webpack have source map support too. I just didn't touch upon it. I don't know what. I don't know. Right. I mean, so JSPM, like, my impression of it is like, it's such a great idea, but like, there are these things that I just don't understand about it, these generated things. And so this is, if you look at our modules now, they're ES6 modules. This is ES6 with JSPM. And this next example, you can have all the different module formats at once. So here's add as an AMD module, reduce as a CommonJS module, sum as an ES6 module, and main as an ES6 module, right? So if your project is oriented around like being a JavaScript library that a lot of people will consume, like D3, for example, in this picture, like this circle is our library, and we want to publish it using these different formats. And so if your goal is to publish using different formats and make your module available to as many people as possible, this is kind of what you want to do. You want to release it as all these different module formats. And to produce these releases, these are the tools that I find are the best. Webpack, Browserify, Rollup, and Esperanto, they support publishing 2 different module formats. So this is in the case of like maybe D3, for example. But in the case of another project where the goal is to consume many different modules that may be published in different formats. So here's our project. We want to consume modules like maybe plugins authored as AMD, CommonJS, or ES6. JSPM is definitely the way to go. And like, this is more the case for Chiasm, because I want to have Chiasm as like a plugin system where people can author their plugins in different formats. I don't want to dictate to them how they should write their plugin. Which one of these tools, because probably they're familiar with one and they want to use one particular thing. So that's why I'm thinking about adopting JSPM for the Chiasm loader. Browserify and Webpack may be able to consume multiple module formats at once. I'm not really sure, but I think so. So that's the end. Thank you. Yeah, an ocean of tools. Yeah, ocean of tools.